Okay. So, we're going to talk about a couple things that we've kind of already talked about informally, okay? So the first thing is the fundamental theorem of algebra. If we have a polynomial of degree n, then we have at least one zero in the complex number system, okay? Now we know if we have a polynomial of degree n, there should be n zeros, correct? But they all may be the same, right? So that's what this is saying, okay? There's at least one zero, whether it be real or imaginary, okay? That's why it says complex, all right? If we have a third degree polynomial, okay, maybe all three zeros are the same, but we at least have a zero, okay? No matter what, we will find at least one zero, if not more. This is something that if any of you go on to study theoretical mathematics, this is something that you actually get to prove. Really disgusting. But this is something that you work on, you actually write a proof about why this is true. I will not bore you with that. Now, we have taken zeros and we have written their factors, correct? If I say, hey, 2 and 5 are zeros, you know that x minus 2 and x minus 5 can be factors, correct? Yes? Okay. If we have an n-degree polynomial, we can write n linear factors. No matter how many zeros we have, if we have an n-degree polynomial, we can factor it out to n linear factors. If we have a fifth degree polynomial, we are going to have 5 linear factors. Okay? Linear means what? Okay, but what kind of polynomial? X to the first. Okay, so you see what I have here. X minus something times x minus something times x minus something. These c's are just constants, okay? They can be real, they can be imaginary, okay? We haven't really worked with that yet, but we are going to. Okay? But if we have zeros, okay, we can write all of our factors, okay? If we have a fifth degree polynomial, we better have 5 factors. If we have a third degree polynomial, we better have 3 factors. Can they repeat? Sure, but we better have the same number. Okay, do you remember last year when you wrote a bunch of numbers down and you used synthetic division to guess and check? Do you kind of remember that? That is what we're doing today and tomorrow, okay? It is called the rational zeros test. What? We're going to talk about what you did last year, and then tomorrow I'm going to give you some rules that'll help you narrow down, okay? So first of all, we could just start guessing and checking random numbers, okay? But that is a lot of work. What the rational zero test does for us is we actually get a list of numbers. We're going to narrow it down to just a pool of possible numbers instead of any number we want, okay? So we have a polynomial. All right. Our rational zero is in the form of P over Q, where P is a factor of the constant term. So whatever this is, we're going to list all of our factors of the constant term. And Q is a factor of the leading coefficient. Okay, so we're going to make all of these fractions of factors of this number divided by factors of this number. Okay, so we're going to narrow down our options to any number, to maybe a pool of 10 or 20. Okay. Still seems like a lot, but it's less than an infinite number. All right, so basically, if we can factor a polynomial, that's always going to be our best option, okay? If we cannot factor a polynomial, then we are going to have to use the rational zeros test, okay? If you are not given a zero or a factor, like on your quiz yesterday, I said, hey, this is a factor. Use it to help you find the rest. Okay, you're not going to be given that. So we're going to have to figure out our zeros based on no information. Okay, so first of all, if you can factor a polynomial, please factor it. Okay, that will save you time. Okay, if you can't, then we're going to have to use the rational zeros test. All right, sometimes it's going to be, you know, we try a couple numbers and we find one. Sometimes we'll find one right away. It just depends on what you choose first. But let's go ahead and go through an example. Okay, so here's our problem. I want the zeros of 2x cubed plus 3x squared minus 8x plus 3. Okay, how many zeros should we find? 3. Some of them may repeat, that's fine, but we should at least find 3. Okay. So first thing we're going to do is we're going to list our possible zeros. So first of all, what are factors of our constant term? 1 and 3. Positive or negative. Right? Negative 1 times negative 3 gives you 3. Okay? What are factors of our leading coefficient? 1 and 2. Positive or negative? It's a factor. Because 3, 1 times 3 is 3. Okay. You'll always have 1 and that number. Okay. These are both prime numbers, and so we only have the 2 factors. All right. So let's list these out, please. We have 1 over 1, positive or negative. 1 over 2, positive or negative. 3 over 1, positive or negative. 3 over 2, positive or negative. So we have narrowed down our options from an infinite number of numbers to 8 numbers. Okay. Does it seem so bad when you look at it in that perspective, right? Now we are going to set up our synthetic division. 2, 3, negative 8, 3. And our goal, do you have a question? Okay. Our goal is to get what right here? We want a remainder of 0. Okay? So let's look at this list of 8 numbers. What would you like to try first? Positive 3. Sure.
Oh no, 5 more is fine.
Okay. My suggestion is to always start with 1 and negative 1. Because they're easy to multiply. Okay? And then I'd work out from there. So let's try 1, you say? You change your mind to 1? Okay. So drop down the 2. 2 times 1 is 2. Add to get 5. 5 times 1. Add to get negative 3. Negative 3 times 1. Look at that. Good thing you changed your mind.
Only 52 tries.
Okay? Alright, so this was nice. We got it right on our first try. Okay? If we did not get a 0, okay, please do this in pencil. Okay? Because all you have to do is erase this, and you can still keep your synthetic division set up. Okay? You can use your eraser. Please use your eraser, otherwise you're going to use a whole piece of paper for one problem. Okay? So, now where can we go from here? Okay. What kind of function are we left with right here? We started with a third degree, so we're left with a second degree. Once we have it down to a second degree polynomial, you are either going to factor or use the quadratic formula if you have to. Okay? Do not do the rational zeros test anymore once you have a quadratic. Okay? So, try to factor this. Okay, well, how do we get 2x? We need a 2x and x, right? What's minus 1 here?
Yeah.
And plus 3 here. So then we get positive 6x minus 1x. Seems good to me, right? Okay. So what are our zeros? What does this give us? What does this give us? Is that it? Don't forget to list 1. Were all of these a part of our list? Yes. So if we would have tried 1/2 first, you know, we would have gotten a remainder of 0, but who would try 1/2 first? Okay. You're going to save that to the end probably because it's a fraction, right? All right, but here are our 3 zeros. Now, what if I asked you to write this as a product of linear factors? What does that mean?
Would you like x minus 1/2, x plus 3, x minus 1?
Yes. Yes.
In your factoring, how'd you get 3 and then get 1?
We got to multiply to get 3.
Yeah, but added together, don't those have to equal to 5?
Well, but 2x times 3 is 6x, negative 1 times x is negative 1x, so add those together. Okay? You can use whatever method you want to factor, okay? I'm not going to go through that process up here, though.
Okay.
So if you want to use the Greeble method, that is fine.
What is the Greeble method?
That's what I'm going to call it. I don't know. Okay? All right. Now, number 71 over there. We had imaginary zeros, right? Okay. What do you notice about the 2 zeros we got for number 71? We have 2 plus radical 2i and 2 minus radical 2i. What are those? Complex conjugates. Anytime you get a complex 0, it will come in conjugate pairs. If you have an imaginary 0, its complex conjugate is also a 0. Why do we need to know this? Here, I have a fourth degree function, and I'm telling you that 1 plus 3i is a 0. I want all of the zeros. Okay. So how does this help us? If 1 plus 3i is a 0, 1 minus 3i is a 0. Okay? Now, here's the thing about the rational zeros test. I'm going to come back to this slide. Okay? What kind of numbers are these? They're real. They're rational. Is it possible to have a 0 of like square root 3? Negative square root 3, square root 2. Okay? So this rational zeros test, this does not give us all of our options, okay? Only the rational options, okay? So what we need to do here is we need to use the fact that we have 2 zeros to help us, okay? So if 1 plus 3i is a 0, what is its factor? How do you write a factor? If 2 is a 0, what would be a factor? X minus 2. If 1 plus 3i is a 0, what would be a factor? X minus 1 plus 3i. That's how we write factors, right? X minus the 0. Wake up, people. I'm not the only one that's a part of this lesson. Okay. You also told me what? Also, 1 minus 3i is a 0. I have 2 factors of my polynomial, which means they will do what to our polynomial? If we have factors, what happens when we divide? They divide evenly, right? Okay, now do we want to divide by x minus 3, x minus 1 plus 3i? No, we don't. Okay? But what we can do is we can multiply these together and get a polynomial that has no imaginary numbers in it. Okay? So I'm going to rewrite these to where I don't have those parentheses inside anymore. Okay? Okay. This looks kind of familiar to you. Remember when we did those graphing packets and we had the 1 plus square root of 3? Okay? Same kind of thing here. So I need to multiply these 3 terms to these 3 terms. So here we go. X times x. X times negative 1. X times 3i. Okay? Negative 1 times x. Negative 1 times negative 1. And negative 1 times 3i. Then we have negative 3i times x. Negative 3i times 1. Negative 3i times a positive 3i. Okay, it would be a positive 9, wouldn't it? Because we have negative 9i squared. Let's just change it to positive 9. Cool, what happens? 3ix cancels. 3i's cancel. And we're left with okay. Can we use this to help us? How? Get factors to this.
Use that for division.
What? Okay. We know that this should divide evenly into this fourth degree polynomial, correct? And if I take a fourth degree polynomial and I divide it by a second degree polynomial, the quotient is going to be a second degree. So here we go. What kind of division do we have to use? Oh, long division. Heaven forbid. So, x squared times what is x to the fourth? X squared. X squared needs to be multiplied to all three terms, so we have x to the fourth minus 2x cubed plus 10x squared. And we do what here? We subtract. Okay? So what are we left with? We'll bring down our 2x. So, x squared times what is negative x cubed? Negative x. Good. So we have negative x cubed plus 2x squared minus 10x. And we're going to subtract. Alright, what are we left with? Plus 12x minus 60. Now this better divide evenly. That was the whole point. Okay? X squared times what is negative 6x squared? Negative 6. So we have negative 6x squared. We have positive 12x. And we have negative 60. Good thing. Okay? So here is what we get when we factor out our two imaginary zeros. What can we do with x squared minus x minus 6? X plus what? Times x minus 3. So our zeros are negative 2, 3. Well, what were they? That was a long time ago. 1 plus 3i and 1 minus 3i. Since they're conjugate pairs, you can write them together. I am perfectly fine with that.
And that's just one problem.
That is one problem. You will have one problem like this on your homework. Do not skip it. I will not give you full credit if you skip this problem. Okay. Now, let me go back to this problem right here. Notice how we only had to do synthetic division once. If this was a fourth degree polynomial, it's possible that you'll have to do it twice. That is fine. If you're going to do synthetic division a second time, make sure you do it from the result. Okay? Never go back to the original once you have found a zero. Always use what has been factored out. Okay? Otherwise, you're just going to go in circles. Okay? So make sure once you've done synthetic division once, if you have to do it again, go from the result. Okay? I believe you had a problem like that, number 59 the other day, where we had to do that. We did that one on the board, didn't we? You don't know what I'm talking about? Yes? Okay. If you have a fourth degree polynomial, more than likely you'll have to do synthetic division for a second time. Okay? Now, I'm not giving you a terribly long assignment.